So the last thing you need to do is to multiply your pressure times your volume column together. So here's your pressure, 745. Take your volume, so P times V. So P times V would be, one example would be 880.0. That would be millimeters times my pressure, 745, also millimeters. That comes out to be with sig figs 656,000 millimeters squared. So that's how I come up with this last column. All you're doing is multiplying these two together. Now, it's a big number. And the group's data that I used here, they had a small leak in their tube. But for most of you, your numbers should be pretty much constant, okay? And even with this small leak, it's pretty good. 656, 657, 655. It's not changing very much. And so looking at your data, you could say that pressure times volume equals a constant, right? This is Boyle's law. Take any volume times its matching pressure, it will equal a constant. In other words, I could say if this is P1, or if this is V1 and this is P1, and this is V2 and this is P2, they should equal the same thing, right? V1 times P1 gives me this, and V2 times P2 gives me essentially the same number. So the other way you can express Boyle's law is P1 times V1 is equal to P2 times V2. And so you've derived Boyle's law. You derived Charles's law, now you've derived Boyle's law. Another difference to point out here is what's happening to pressure as volume decreases? Increases. So the relationship between pressure and volume are inverse. As volume goes down, pressure goes up. That's different than Charles's law, where as temperature goes up, volume goes up. So let's see here. What can I give you for homework?
Can we do the questions together?
You can try, I mean, if you want to try graphing at home, you can try graphing at home.
I chose a computers better, so.
Otherwise, I will try to get computers for us on Monday to graph with. Okay?
So Charles, you have a dead fish in there.
No, I don't.